Good afternoon. Today we're going to look through chapter 14 textbook. I set you 4 questions to do, so it was the 3 yellow questions within chapter 14 and exercise question 2 as well. So I'm just going to do a walkthrough to show you the answers and how to approach each question. So chapter 14 yellow question 1 asks you to produce assembly language, assembly code to input a number and calculate an output 6x minus 5. So what you'd actually calculate is you'd input a number and it would multiply that number by 6 and then subtract 5 to give you an output. So the first line in the assembly code would be IMP, input, because you want it to, you need to input that first number, which is the 5 that we're going to subtract. So that needs to be put in. You're then going to store that value of 5 in that variable part of the memory called 5. Next up, you then have to input a value into the accumulator. So that's going to be the value x that you're going to key in. Then you're going to store that value in x. So you input the value and then it'll be stored in x. Okay, so just the value that is keyed in, the actual number you key in, will be stored as x. Next, what you need to do is add x, add the value of x to the accumulator. And by adding the value of x, you've now got the equivalent of 2 times x. Okay, so you've got x, you add x again, gives you the equivalent of 2x. Then what you need to do is add x a third time, or the instruction to add x a third time to the accumulator. We now have the value of 3 times x, 3x. Next up, you're then going to store that value of 3x. So it's stored as called 3x is the value of 3 multiplied by what x is, whatever value is typed in. You then add 3x to the accumulator. So remember, we've already got 3x added to the accumulator. If we add another 3x, that's the equivalent of adding 6x. Okay, the equivalent of adding 6 multiplied by that value of x that you've keyed in. So you store x, add it again, gives you 3x, store that 3x, add it 3x, gives you the equivalent of 6x. So that's that part of the equation. Now you need to subtract the value of 5. Remember, we've input the number 5 initially. We now have to subtract that value of 5 from the equation. Out is your next instruction, because you're going to output that number in the accumulator. And that's halt the program. That's the end of the program there. So you've input the value 5, you've stored it, you've inputted the value x, or the user would input the value x, add the value to give you 2x, add it again to give you 3x, store that as 3x, add 3x to 3x gives you 6x, subtract the value of 5, then you have the value, that number's output in the accumulator, halt the program. Not quite done yet, because you now have the dat values to add, and you can see there you get the x value, the 5 value, and the 3x value. That's the value stored there. So that would give you your answer to that question. Input a number and calculate an output 6x minus 5. Okay, so that's your assembly code there. You can see on the screen. The information after the semicolon is the explanation of what each bit of assembly code actually means. Okay, so let's have a look at question 2. So chapter 14, yellow question 2, asked you to provide the assembly code to input 2 numbers and output the minimum number. So you're inputting 2 numbers and it wants to output the minimum of whatever those 2 numbers input are, the lowest number. So you start with INP as your code. Next up, you're going to store in the accumulator the number 2, so the second value first. Input the first value, number 1, call it number 1. You then subtract number 2 from number 1. And then your code now is BRP first max. So BRP code means branch if positive. What that means is it's conditional, because remember you're looking at to find the minimum number between 2 values. So you branch if positive. So you branch to the address given in the accumulator if it is 0 or positive. So because you're subtracting value 2 from value 1, If value 2 is smaller, then you're going to have a positive answer. If value 2 is the same, you'll have a 0 answer. If value 2 is higher, it's going to be a negative answer, but you're only branching this to the accumulator if it's a positive answer or 0. You then load in number 1, the value that first value of number 1 that was entered. You output number 1, and that will give you the lowest value between the two. They give you the minimum number. If you want to try that code in the Little Man Computer website, I'll show that at the end of the presentation. You can see that code running and working. So that's your answer for chapter 14, question 2. Input 2 numbers and output the minimum number. If you look carefully read through the chapter, you'll see just before that question, it's got a similar bit of assembly code for inputting 2 numbers and outputting the maximum number. So just compare that code example in the book with this code you can see here. Okay. Finally, of course, what I haven't done is we need to halt the program, and then of course you've got the first max, you're loading into the accumulator the number 2. Okay, you're outputting the number 2 and then halting the program there. It'll give you the value. So you've got the branching off. If it's 0 or positive, and it'll give you the value of the lowest number, the minimum number. Okay, question 3. You have pseudocode. So you've been given in the example quite a large bit of assembly code there, and you're asked to, in the question, which is on the next page, the yellow question 3 is asked to give the pseudocode of the following assembly code. Now, the key thing about this, good exam technique, is read the question. Because if you start to look at this code here, look at all that assembly code that you can see there, you might be thinking, there's quite a lot of work here to do some pseudocode. But if you look at the actual question itself, what it's asking you to do is fairly straightforward. So the pseudocode for this question is straightforward because it actually says, write an assembly code program which performs integer division, so dividing whole numbers. The program inputs 2 numbers, one called big, one called small, which are 2 inputs, and outputs the result of big divided by small, ignoring any remainders. So you're inputting 2 numbers, one called big, one called small, you're dividing big by small, and you're outputting that result. So that's what it wants you to do the pseudocode for. So in the question, don't worry too much about the detail of the assembly code here. That's what it's asking you to do. So that is what your answer is. So having a look through that. So first of all, the first piece of pseudocode is big. The variable big needs to be input. The value of the variable small needs to be input. Then you need to provide an answer, and the answer is calculated with the big number divided by the small number, so big div small. And lastly, you're outputting the result, so you're printing the answer. So printing that variable called answer, which is big divided by small. So very, very simple, very straightforward pseudocode. Don't be caught up by looking at the complex assembly code and thinking pseudocode needs to be complex. Read the question, read what it's asking you to do, and you can see actually it's a fairly simple program, so therefore the pseudocode is fairly simple as well. Finally, on to chapter 14, the exercises. So I asked you to do exercise question 2 on page 73, and you have some instructions here. So using the instructions, add x, add number stored in x to the accumulator, load x, load into the accumulator the value stored in x, and store ax, stax, store the value in the accumulator in location x. Write an assembly language program that adds together the values stored in memory locations num1 and num2, storing the result total in memory location num3. Okay, so it's a 3-mark question. So let's look at the assembly code for that. Use the marks as a guideline to how detailed this code needs to be. So first of all, what you're going to do, first line in assembly code is LDA number 1, so load the value num1 into the accumulator. You then add the value num2 because you're adding 1 and 2. You then store that result in the accumulator as num3. It's as straightforward as that. Load LDA num1, add num2, STA num3. Load number 1, add number 2 to that value, store the answer in the accumulator, which is called memory location num3. So you can, with those assembly codes, I suggest what you do is look at the assembly code that's in chapter 14, put that assembly code, go to the Little Man Computer website, the link you can see there on the page, peterigson.co.uk/LMC. The screen will look like that when you load up the site. Put in that assembly language code in that you can see in the textbook, or you can from the answers in this slideshow, and you can see the results and what happens when you run that computer, how it addresses the memory, how it loads the information in, what results you get in the output, where it's loading in the accumulator. So it just gives you a bit of an understanding how assembly language actually works in relation to memory as well. Okay, so a little exercise for you to do: get the assembly code from chapter 14 and the answers today, key it into Little Man Computer, give yourself a bit of a better understanding of how assembly code works in relation to memory. Okay.